back. Now we're in the practice of a design and implementation of a band control using a step motor and end of a stroke detection using an optical sensor, and we are going to be indicating the sensor with a buzzer or LED. So basically we're using three components. As you can already tell, we have the motor control, we have the optical detection with a sensor. In this case, we are using the FC51, and an indicator. In this case, we are using a green LED. But in this case, I'm gonna be explaining the code. So in the next video, I'm gonna be explaining the physical part and how it's connected. So first, we have these three libraries. Are the same as always. We are using the STD Logic 1164, the STD Logic ARITH, and the STD Logic Unsigned. So the provided VHDL brings with the inclusion of standards libraries. So these are necessary for using the STD logic types. So we are using arithmetic operations. The entity name is Banda. You can name it whatever you want. In this case, I put Banda because it's the Spanish word of band. So the architecture itself has a state machine and is declared with the Banda entity. Now, we have the inputs and the outputs. So the inputs include the CLK or clock of 50 megahertz as an input, the RST or reset like an input, the CLK as an output, the receipt as an input, the counter as an output, the FC51, this is the sensor I was talking about earlier in the beginning of this video, and the buzzer. In this case, this will be the LED, so it's as an output. Now we have these lines over here, the signal, the alias, the type, and the signal. So the signal is clock tempo, it's like temporal, equals to STD logic vector of 25 down to 0. In this case, 25 down to 0 is equal to 26 zeros. So we are using the alias to have this clock temp with 15. Why 15? Because this will be way faster than 25. So I've managed to discover that the number 15 is a very good number to have this working on the physical part because it will be fast and it will move the band. If you have it in 25, maybe it won't move. The motor will move, but it won't move the band. So I recommend it to use it with 15. Now, so the lower section of this state machine is managed by a process that controls the state transitions. This process updates the current state of PR state to the next state on the rising edge of the dividing clock signal. Unless the reset signal is high, if reset is high, the state machine resets to 0. This process ensures that the state transitions occur synchronously with the divided clock signal and can be reset as needed. So the upper section, this one, of the state machine defines the state logic and output control. This process determines the behavior of the system based on the current state and the input control signal, in this case the signal of the FC51. If the FC51 or the sensor is low, the state machine resets to 0 state and the buzzer is active. So it will be a buzzer or a LED. In this case it's a buzzer, but you can put it a LED. So if the buzzer is set to 1, it means that the FC51 is in low, but if the FC51 is in high, the buzzer is deactivated and the band will move. So the state machine transitions through the predefined sequence of each state. So each state sets the specific values to the counter output and determines the next state. For the subsequent clock cycle, the states transition in the flow sequence will be from 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 and then to 0, like a state machine. This process encapsulates the core logic for the band control system, managing state transition and output signals. As you can see, it will be from 1, 2, 3, 4, 5, 6, 7, 0, and others it will be 0. So it's pretty much that. And now let's jump to the physical part.
Hello, welcome back. Now we are doing a step motor with a sensor FC51. So this is the sensor over here. This is the step motor connected to a band to transport an object, and when the sensor detects the object, it will stop. So if the sensor doesn't detect anything, it will let pass. So I'm gonna put this box over here, and you will see that it will stop. It stopped. But if the sensor doesn't detect anything, like this, it will let it pass. Just like that. And when the sensor detects an object, like that, that LED over there is going to turn up. And that's everything. That's the sensor over there.